Hi, Glenn. Okay. So, I don't know where they are. Before we begin, I will say this is our last meeting, and Mr. Kingsland is busy next week about the end of year, so we won't have a meeting next week. This is our last meeting for our school year. So I just wonder, what kind of activity do you want? Because I haven't thought of a good idea yet. Just do some programming as usual. Okay. Seems like you like programming. Okay. Continue with Code Forces. Okay. Yeah, because I think this is a good site. We were at, oh. Okay. So where were we? Where we were at? I'm not sure. We are done with these two questions, I think. We can start from the team. Okay. This is our last meeting for the year. And after this meeting, we will not have any other meeting, and I'll graduate because I'm grade 12 now. Okay. But I think we can, I don't know if you want, but during the summer, I can post some practice and I'll post the solution on the classroom, or I can send you through email. If you want some practice going on, it depends. Okay, so we are going to solve this problem. Yeah, Cerebral Classroom. Okay. I'll also post some like solution approach and my solution code, I think. Okay. Code share again, I think. I haven't found any other sites, so we'll just use this one. Yeah, so you can enter the same site. Oh, okay. So once we get a question, as we usually do, first we will think what is. So this problem involves, let's say, it's more like a simulation problem. The simulation means we are simulating a real life problem. Using. So this is the most common. May not involve any simulation. So this seems to be a simulation problem. Since it's not on graph, it's not about math, it's, or sometimes, or some people call it construction problem. So you will create special way to solve. So it's special. And hi, Mr. Kingston. We are solving a problem now. Okay. Yeah. So every time we meet a simulation. Hi, Mr. Kingston. Okay.
Hello, how's everybody doing?
I think. Okay. Good. Okay. So every time we meet a simulation problem, most likely we will have to discover a special method for each problem. So we don't have any kind of general solution to this stuff. So let's see, what does this problem do? So we have 3 people in the programming team, which is called Petya, Vesya. Okay, so whatever. So if at least 2 people are sure about the solution, they can implement it. Otherwise, they won't. Okay. So before we start writing the codes, we want to simulate the problem manually. So, or maybe we'll just, say, write down some simple conditions. So say if 2 or 3 people are sure solve it. Otherwise, we don't. So this is the general condition, right? Seem to repeat the first number, add 3 numbers. If 2 or less, add 1 to the final number. If not, skip to next. Okay, I would say this is a good approach. Yeah. Okay. About Glenn's approach, I would say okay. It's either, oh wait, my keyboard doesn't work. They're either 0 or 1. So if 2 or more, and the sum is 2 or larger than 2. So it's total equal than 2. Yeah. Okay. So about we want to write pseudocode. So let's say C++. Yeah, so once we get the question, we can start implementing. So if we want Kara and Glenn, you can, if you want, you can write some codes. So we want to total number of columns. We want to read the if I were to cn 101, would it stay? What would it be the correct type to store? Oh, so we can divide this. So if you get, you get three numbers like 0, 1, 0, what we can do is we will use in for 3 times. So you can read each of the number. So you can read the first, then the second, then the third. If you want to put it as the sum, so you can, let's say I will use cin9. It stop once space bar or a new line. So we can use like sum plus equals none. And kind of do this. Yeah. Or you can just use 3 variables, both are fine. Yeah, I think both are fine. Do this much more. Usually we may not write the most efficient code when we first solve a problem, so that's fine. What I have repeat the same type of code better than I don't really understand what you mean by that though. But I think using loop is more efficient though. Yeah, rather than using repeating same codes, right? Oh yeah, because the loop does the work for us. We don't want to do it manually by repeating the codes. Yeah. Yeah, so that's an important thing. If we can use either a loop, or if we find something too long and we use it in, let's say, in different code, we can write it as a function. So if we want to reading a number and the certain operation, And this happens, let's say, at the beginning of the code, and at the end of code, we can just write a function. So we can solve it once for all. So yeah, we'll try to reduce the redundant code if possible. Yeah, I think I should start having a kind of like a formula sheet or something. So we can use this one. Okay. Let's say loop. Okay. So yeah, this is kind of standard stuff. Yeah, we can, if you write many codes, if you write the same code for many times, you will use it for every time. You can either, let's try to put it onto a sheet so you can understand what's your pattern, like doing the routine, or you can, I don't know, you can use the same codes again. That's also fine, and save your time from writing the same code. Yeah. Yeah, so after we write the code, we'll start debugging. And good habits in writing the code can save us many time from debugging. So it's important to know the routine so you can write better codes that save your time from debugging for, let's say, a few more minutes. Okay. Also, we can use the sample case to test it's correct. So the tool I'm using now, it supports that, so I will try to use it. the num is not declared in the scope, right? It's now caused. That's what that's oh, okay, I see. So from the code we can see some yeah. So for here first, this is the counting part or the condition part. So if you write b equals 3, this is true by default. So it will keep running. Yeah. Okay. Let's try again. Okay, so the result. Oh. So we can see from our formula sheet that I wrote before, we want to run the code for n times, we'll just use n because we start counting from 0 less than. We'll count exactly n times when we end at n minus 1. So if we want to count 3 times, then n equals 3. We'll just kind of plug it in. Yeah. So if we want to make some changes here, I think. So it should be smaller than total because we want exactly total numbers. If we smaller or equal to, we will count for extra one time. This doesn't influence the result, but it's not good, I think. Yeah. For loop, when using for loop, we don't need semicolon at the after the braces. So it can be a pattern, kind of a pattern that usually we don't add semicolon after braces. For most cases, unless there's a special case, but we don't use that pretty often. So after braces, we shouldn't have any semicolon. Yeah. I'll just copy and paste these to here. And read this part. Yeah, it's important to note that when initializing a variable as local variable, it will be given a arbitrary value, a random value, unless we give it a value manually. So inside the code, if let's say we create a variable called answer, if we doesn't give it value at first, it can be anything like 1 million or maybe 15. So we have to initialize it manually to 0. Yeah, and when using for loop, we want to loop for n times. We have two ways to write this. We can write it as equals 0. It can start from 0 and smaller than n, or start from 1, smaller or equal to n. Both are okay. most people are kind of the end zero style, I think. But some people start counting from 1 and it doesn't really matter. But arrays usually start the index at 0, so from habit we use 0 more, I think. Yeah, so if before you make operations on a variable, a global variable, or it has to be initialized, otherwise it will cause problems that we can't find. So we can initialize this to 0, 2. Yes. Yeah. From what I test here, we test all the cases. Left here after the brace though. Here, yeah. So I will just add another line. So braces in most while. So do while it's not used really common, so we will skip for now, I think. Okay, so I think our code is fine now. After making these debuggings, we can we passed all the cases here. So from the two I use here, we can see expected result. So we can head to the code now. We can submit the code. Okay, and we get accepted, which means our code passes all the test cases. Yes. So it took the program 62 ms to solve all the test cases. Yeah. So we're done with this problem. Okay. So what we learned from this problem, we haven't learned any new algorithm from solving these problems, but what we learn from them is firstly firstly we learned the routine. We kind of review the routine for solving the problem. Secondly, let's say the initialization. Local variables. The third thing is, let me see. Yeah, the use of loop. Use of for loops, especially. We can use while loop instead. Both are fine, I think. Yeah. Also, I'd say the use of sum. So some people solve this by using multiple ifs. They will say, if this is, but I think using sum is a much more efficient way. So we'll just use sum here. Okay, so these are something that we learned. Oh, also the 5, I think. No braces, no semicolons after braces. Unless using while. Do we have any question now on this problem? No, not yet. What about Kara? Okay, then we okay, so we've solved, I would say, 5 problems on 800, and we can use another site now. Another site has a different style, so we won't be stuck in one fixed mindset. That's quite important. So let's wait. Okay, let's play a math problem. Okay, I don't like this problem. This problem is not so nice for us. Yeah. Yeah, string problem. So string problem is also an important one, important type of problem that we usually solve. We'll be processing string or finding special string, or let's say creating a string that fits some special cases. Okay. Okay. So this is string palindrome. So before we solve this problem, I'll just quickly introduce palindrome. So palindrome is a word which reads the same backward as forward. So these are some examples, like race car, yeah, and 12021, some stuff like this is palindrome. So we are just dealing with palindrome now. Palindrome is a popular topic in competitive programming, but when dealing with string problems, we may use, so for string, use already here. So for string, either string algorithms. So depending on how the difficulty will be, we'll either have to use some string functions, something like string.length, string.size yet, or we will have to write some string matching algorithms, which is used to match one string with another string, substring, those stuff. But we haven't learned those yet, so we're most likely to be using string functions for now. So yeah. So for the problem, it says as a string, it's said to be a strong palindrome if and only if these are satisfied. So it has to be odd length first, which is satisfied for all input. That's nice. We don't have to check if it's odd number. It's palindrome. The string formed by the first through n-1/2 characters. The string consisted of the n+3 second through nth character of S is a palindrome. Determine whether S is a strong palindrome. Okay. So for these kind of problems, it's already complex enough that we may get lost just reading the problem. So the best way to do this is, if you do have pen or pencil, you can just take out a piece of paper. We can start simulating the problem now. I'll use a drawing board here. Yeah. So some important numbers that we have to think about. So firstly, n be the length. So n is the length. The string formed by the first through n-1/2. Okay, so first to n-1/2 is a palindrome. It's a palindrome. And the n+3/2 to nth is a palindrome. n+3. Okay, so this seems still complex to us. We can just use a string, let's say a length of, so when n equals 5, we can create such a string. I will call it whatever string. Hat, AH. So hat, whatever it is. The first is H. So we start from H. n-1, so n is 5 here. N equals 5, so it's 5 minus 1/2 is 4/2, it's 2. So the first to the second, so HA, and let's see here, n equals 5. So n+3/2 is 8/2 is 4. So the fourth to the last, which is these, is a palindrome. Okay. So from what we know here, n has to be odd. So this pattern should apply to all the strings, which means the first to the one before the middle one, and from the one after the middle to the end. So there are two strings being separated, and each of them has to be palindrome, and the overall string has to be palindrome. Then it's a strong palindrome according to the definition of the problem. So let's see if this pattern works for all. So we will try 3 again. So if we have, let's say, AAA, a string called AAA, n equals 1. So n equals 1. n-1/2 is, oh, never mind, n equals 3. Yeah. n-1/2 is 1. So 3 minus 1 equals 2. 2/2 is 1. So start is just the first character. It's a palindrome, yeah. Because the character itself is a palindrome, this applies to all characters because your first letter and your last letter is both yourself. So they are the same, yeah. So from here, m plus 3 over 2 equals 3 plus 3 over 2. So from the third to the last, just your first half has to be palindrome. Your second half has to be a palindrome. The overall string has to be a palindrome. Then it's a strong palindrome. So it has 3 steps. Okay. So we know the pattern now. Any question on this or we're finding process? And you can also send in the chat. I can see the chat now, I think. Or you can just type on the code share. Okay. Seems like we don't have any problem with it. Okay. So we can use sample cases to examine. Also find the pattern. Yeah, sometimes the problem writer will provide some explanation, which is useful for us to solve the problem. So we check the sample input 1, which is aka SAKA. So the overall string is a palindrome. If we start reading from the frame, aka SAKA, aka SAKA. Okay, so it meets the first requirement. Then the first to the one before the middle, aka a palindrome. The second half, aka a palindrome. Okay, so it meets all conditions. So the result is yes, which is a strong palindrome. Okay, then we'll go from the second word level. The overall is a palindrome. The first half is LE, which is not a palindrome. So it's not a strong palindrome then. So we output no. But at coder, the overall string is not a palindrome. Then it doesn't even fit the first condition. So the answer is no. Okay, so now we are sure that our understanding is correct. The next thing is to think of a way to see whether a string is a palindrome or not. Yeah. So palindrome. So there are 2 ways. Before, if we want to do something for multiple times, the best way is to write it as a function. So every time we want to do the same task, we can just call the function. We don't have to write the same codes for again. If the codes take like 10 lines or more, it's a waste of time and life, I think. So we can just write a function called returns a boolean, returns a bool value as palindrome. So we input a string. Oh, yeah, just test it. So we use this to identify, to check if the string is a palindrome. So here we have to use this function for 3 times. We have to see the overall, the first half, and the second half to see if they are palindrome. So what are some ways to find a palindrome? So there's a function in string. So I'll just write it here. So There are two ways. The first way the first way we can use you can use string functions. We can reverse the string and compare with the original string. So there's a string function called reverse. You can have a string, make a copy, you reverse the copy and compare with the original string to see if a string is the same as a reversed string, then it's a palindrome because it's the same from either forward and backward. So this is the first way. Second way, as I think it's from last meeting, yeah. So string as a special type of array, character array. So we can use index to compare the letters from one by one. So if the first letter is the same as the last letter, the first letter is same as the last letter, the second letter is same as the second last letter, and goes on, then it should be a palindrome if every two letters match, or maybe there's one letter left in the middle, it still matches. So both two ways are fine. Using the first way, you can save yourself time. Using the second way, okay, let's use the first way. Another problem caused by the second way is if the string gets larger, it takes much more time. Yeah. Or there's even a third way. You can copy a string. You can copy a string letter by letter from the, let's say from the end of the string, put it into a new string, and compare with the original string, which is also a way, may not be as efficient. Yeah. So let's implement this. I will just write some codes for it. Any question on it? You can type in the chat. If you have one, you can type 1. If you don't have one, you can type 0, or just type stop saying Kevin. Just write the codes and both fine. Okay. Okay. Now we will just implement this palindrome method. So from the parameter, we pass in a string called str. We'll create a new string called copy equals string. So by doing this, we make a copy, taking the value of the original string. So we find ourselves unfamiliar with any of the C++ functions, we can just search up on Google. We can find all of them there. Okay, so we can use, where is it? Yeah, so reverse a string, we can use reverse the string name dot begin and brackets, name dot end brackets, a semicolon. And if, let's say, copy equals original string, then it's a palindrome because after reversing it, it's the same as the original one. We'll just return true. Otherwise, return false. Or maybe we don't need this else, it's redundant. Does anyone have idea why this is redundant? Okay. Does anyone want to answer this question, or I'll just keep going on? Okay, I'll keep going on then. Okay. There are only two situations. The two strings are either the same or they are not the same. So if they are the same, it returns. They're not the same, it doesn't return here, then we'll return here. So we don't need to write an else for this, because return does the shortcut for us. If it's true, it just returns. We don't need an else to prevent it from second return. It will just return once and quit this function. So we don't have to write the else for it. So this is the function to check if the string is a palindrome. I just put the implementation here. And by using this function, we can check if the string is a strong palindrome or not by using the function for 3 times. So we can, if you do want to implement this, you can implement it yourself, I mean, or you can just use this function and write the other code yourself. Okay. Any question on this, Glenn or Kara? Nope. Okay. So this is easy to you guys, right? Okay. Palindrome. If so, the use of string functions are the basic part. String algorithms gets much harder, but they are not used so often. So string functions are most often used, just the most basic ones. So find the sites and reverse and then begin. And different from other languages, different from some other languages, in C++, when we are comparing the value of two strings, we can use double equal sign. We don't need to use dot equals, which is different from Java. That's one of the reasons why I don't use Java that often now. We will take the shortest path, right? That's not it's not all the reasons, but part of it, I think. Okay. So if we do have time, we can, so this is the last meeting for the year. And it's 4:55. So I think our meeting is going to the end. Okay. So I'll post these the links for these problems and the problem set in the classroom during the summer or maybe after the school ends. You can solve these problems if you do get time, and give some time to Mr. Kingsland. Yeah.
Hey, if I can just jump in for a second and just say a little more formal thank you to Kevin for all of your hard work. Yeah, really, Kevin, absolutely outstanding stuff this year. Thank you so much for your commitment and for putting the lessons together, the lectures. I didn't have to do anything except for, as you can see, sit in my backyard today. So thank you. Really, truly outstanding work.
So, I don't know. I will graduate, so it's the last time having meeting with you guys. Enjoy, I think. So I will also post more practice. You can suffer more by solving them. Yeah. I think that's the end of meeting. Okay. Yeah. I'll definitely post more like materials, some solutions in the classroom. Don't give up though. we have a competition next year. CCC will be held next year again, I think. So if any of you want to participate, you can definitely get an award. Maybe get some nice, I would say nice scores in it. So
maybe I should talk
That's
a
it.
bit about the CCC. Glenn and Cara, do you know about it at all? You can turn your mics on if you want to. So competition is run by the University of Waterloo, and it's a national competition. Students from anywhere in Canada can participate. Kevin wrote the test this year. There's lots of possibilities for recognition if you do write it. The other thing that's quite neat about it is they will fly the top students in Canada back to University of Waterloo and put you up for a week and run you through some training. And that would put you into the possibility for scholarships. And Waterloo is considered probably the #1 computing science university in Canada. So that's if you are interested, come and talk to me anytime next fall, and I'll give you the details. It usually runs, I think it's February, isn't it, Kevin? Is that when you wrote this year?
Yeah, February. The first stage is February. The second stage is, I think, March or May.
Okay. So if you're gonna, if you are interested, we want to get you registered in the fall at some point. You know, November, December, just so that you're up and ready to go.
And I think one more sentence. The problems that we solved today is like the second hardest, or maybe the hardest for junior division. You can even run senior division if you do spend more time in the upcoming like school year. So better than what I was. So good luck, I think. Good luck. Yeah. That's the succeeding. If you are in junior division, you can probably get full mark. Yeah.
Wow.
Not unsure about the senior though. Yeah.
The senior questions get pretty tough.
Yeah, they are pretty tough. Solid. Okay. Any other words, guys? Okay.
All right. Have a good one.
Have a good one. You too. See you.
Okay, so Kevin, if you want to